In this lecture, we're going to talk about the sample proportion confidence interval and find a way of estimating what fraction of the whole population a particular category represents. So this is categorical data, and we're thinking about what portion of the population shares a particular trait or belongs to a particular category. And in order to do this, we're going to refer to the material Part 1, Lesson 3. We'll be interested in using the population mean to estimate the population proportion. So x over n estimates x over p. X over n estimates p. And in doing this, we'll be applying the central limit theorem. So we have to have sizes of at least 30, not 3, but 30. And so in fact, sample sizes of at least 1,000 are needed in order to get good numbers for this. And so this will take us back to the Bernoulli experiment. Recall in the Bernoulli experiment there are two outcomes, either success or failure. And the probability of success is p. And so this turns out to be, it is a binomial experiment with n equal to 1 trial. And so in applying our binomial formula n times p for mu, or expected value, the expected value of our Bernoulli random variable is p, and the variance is going to be p times 1 minus p. Okay, and so of course the standard deviation is the square root of this. And so this is going to lead us to having a margin of error equal to E is z sub alpha over 2, where alpha is obtained as it has been previously in terms of our confidence. And we'll have our standard error of the mean, the square root of x over n times 1 minus x over n, all divided by n. So how do we get this? Well, the calculation goes as follows. Our standard deviation is the square root of p times 1 minus p. You know, square root of n is just square root of n. We do our algebra extending the square root over both the numerator and denominator. And then we use the fact that x over n is an estimator for p in order to simplify this down to be able to get our standard error of the mean in terms of data that we have. So an example of this, if we choose a sample of size n equal to 1,000, and in that sample there are 222 successes. If we do a 95% confidence interval, we'll have x over n is 0.222. 1 minus x over n is going to be 0.778. Working our formula from the previous slide, this will give us a standard error of the mean as 0.013. Our table lookup with 95% confidence, or our PPF calculation, will round off to 1.960. And again, plugging that formula will give us a margin of error of 0.026. And so leading us to our confidence interval, okay, we take the 2.22 and subtract the 0.026. And then on the other end, we take the 2.22 and add 0.026 to get our confidence interval. This says that with 95% confidence we can expect our mean to be between 19.6% and 24.8%.